What is up, Math Superstars? In this edition of Mr. Peterson Presents, I'm bringing to you a live version. And so if you can see up here, I'm broadcasting live right now because my computer is deciding to not cooperate with me. But here we go. We're going to talk about volume of boxes and cans. And so technically we're talking about rectangular prisms, which are the boxes, and cylinders, which are the cans. And so let's go ahead and flip over to my PowerPoint here. Flipping over. Let's share my screen and see what happens. Nice. And so we're over here in our PowerPoint. Let's give this a whirl. Round two. So if you saw my first round, you notice that I made some mistakes. They helped me improve. And so let's go and talk about volume. So volume is the measure of units. So we're talking about units occupied by a solid region. So when we talk about volume, we're talking about what we can fill inside of a shape. So when we talk about this, the units are going to be cubed. And so we have an example right here. And so if we're going to fill up this box right here, whose edges are 1 centimeter by 1 centimeter by 1 centimeter, our label is going to be in cubic centimeters. Because when we have the equation here, we have volume equals length times width times height. We're measuring centimeters, centimeters times centimeters times centimeters, which gives us centimeters cubed. And so that label is important when dealing with volume. So let's go ahead and give this one a try. So we're going to find the volume of this rectangular prism here. And so we have some details here that we need to write out. So we need to figure out what the length, the width, and the height are. So our length is 7.5 inches. Our width is 2 inches. And our height is going to be 4 inches. And so please get in the habit of labeling these sidelines. So it's going to help us, not necessarily in volume, but when we deal with more complex things like surface area, this is going to be very beneficial information for you. So let's go ahead and write our equation out. Volume is equal to length times width times height. Here we go. And our volume is going to be when we multiply these three together. So let's go ahead and do that. So we have 7.5 times 2 times 4 equals, it comes out to 60. And we need a label on this, and so our label is going to be in inches cubed, and since we multiplied inches 3 times. Let's go ahead and take a look at this example here. So we need to label our length, width, and height. So our length is going to be 4 centimeters. Our width is going to be 5.1 centimeters. And our height is going to be in 9 centimeters. And so our label, obviously, since we're multiplying centimeters times centimeters times centimeters, is going to be in centimeters cubed. And so our volume is going to be our length times width times height. Volume is going to be 4 times 5.1 times 9. And let's go ahead and multiply those together. 4 times 5.1 times 9 gives us a volume of 183.6 centimeters cubed. So now when we're talking about volume, we can also find the volume of a cylinder or a can. And so this equation looks a little tricky, but we're going to break it down so hopefully to better help you out. So we have volume is equal to this first part right here. We have pi times radius squared. That actually comes from, that's actually the area of a circle. So in dealing with cans, the bottom parts are the circles. And all we're doing is we're taking the area of that circle and we're multiplying it by the height. So let's go ahead and try it for example number 1 here. So we need to find the volume. We're using 3.14 for pi. And we're going to round to the nearest tenth. And so we have some tidbits of information here that we're going to write out. So our first part is we need to figure out what the radius is and what the height is. So our radius is the center point that goes to the edge, and that's labeled for us as 5 feet. And then we have the height is this part right here going up and down to the top. We know that is 15 feet. So we have a pretty big cylinder here. And so we know that our equation for volume is pi r squared, which is the area for just the circle part at the top. And we're going to multiply that by the height. And so what we can do is, since we already have our radius and our height, let's go ahead and plug in some numbers. So volume is 3.14. Our radius is 5, and we do that squared. And then we multiply that by 15, which is our height. So order operations tells us, let's go ahead and do the exponent first. 25. We have 3.14. We're rewriting everything. So when we go to multiply, we have something to double check our work with here. And you got to remember that, please remember to do 5 squared is 25 and not 10. So our volume here is 1,177.5. And our label, just like our rectangular prisms, it's going to be in cubic feet for this one. So now we're given this lovely can of pineapple juice. Sounds delicious on a warm day. So let's go ahead and we need to figure out some parts here. We have the radius and the height. We know the height is 9 centimeters, but we notice something here is that we have right here, we're given 6 as our diameter for this. And so our diameter, since our diameter is 6, our radius is going to be 3 centimeters. So all we're doing is we're taking half of the diameter to get the radius. And that's going to help us in doing our equation here. So our equation is pi radius times radius squared times the height. So the volume is 3.14, and our radius is 3, and then we're going to square that times our height is 9. 3 squared is 9 and not 6. Let's go ahead and rewrite everything. So we have something to go back and to check our work with. So we have 3.14 times 9 equals, gives us a volume of 254.3 centimeters cubed. And so in this video here, all we did is we are talking about volume of rectangular prisms and cylinders. And so if you're watching this live, hope you enjoy that. Sorry to have any notes for you, but guess what? If you're watching this in class, you have a lovely little notes page. Next step is you're going to do your classwork page that goes with rectangular prisms and cylinders.